Hi, hello, and welcome. Welcome to this series on AWS networking, and we are discussing NAT gateways today. So, let's quickly have a look at what is a NAT gateway. So, let's understand this with an example. So, we have a private subnet in which we have launched one of the resources. This is an EC2 instance running an Ubuntu OS. Now, this Ubuntu OS requires some security patch and updates to be installed, and this is available via the internet. But because this is launched in a private subnet, it doesn't have any back connectivity to the internet via the internet gateway. And that is because since this is a private resource, it is not to be accessible, or there shouldn't be any inbound connections to this EC2 instance or this resource in the private subnet from the internet. So what we can do is that we can use a NAT gateway which will provide it a back connectivity to the internet, but with only an outbound connection and not as an inbound connection wherein entities on the internet can request this resource that you have within a private subnet. And this is possible with a NAT gateway. So NAT gateway stands for Network Address Translation Gateway. So what it does by its function is that when a resource is trying to request for a certain entity on the internet, or it is trying to send request some resource on the internet, what NAT gateway does is that it replaces the IP address of the source with the IP address of the NAT gateway itself before flashing that request on the external network. And similarly, when receiving the response against the request, when the response is received by the the NAT gateway, the NAT gateway replaces the IP address with the address that of the source that requested, and then it transfers over that response back to the source and hands it off. So this is how NAT gateway basically works, and that's the function that defines it, which is the network address translation. And as explained, that function you easily understand now. Now moving on, there are two types of gateways, public and private. The only difference is that with the private gateway, if you're requesting a resource on the internet, as soon as that traffic is reaching the internet gateway, that particular request is dropped off. So essentially, when you are trying to connect to another VPC or other networks, you can use a private NAT gateway internally, but when you specifically want to connect to an internet resource, then you should be using a public NAT gateway. Now for the lab session, this is what we are trying to achieve, and in this basically I will have a VPC that is the default VPC, in which I'll have 3 public subnets, and which are the default subnet, and I've already created a private subnet within which I'll be launching a EC2 instance, and then for that instance to provide a back connectivity to the internet, we'll be launching a NAT gateway and configuring it, and then in order to perform some test whether this private server is getting the internet access or not, we'll be using a jump server which I've already created. It is nothing but an EC2 instance in the public subnet to which you can SSH, and from there you can directly connect to the private server, because you will never be able to access this private server directly from the internet over SSH, because there is no internet gateway attached directly to this private subnet. So since the public subnet or the jump server is in the same VPC as that of the private server, internally the private server is accessible to the jump server. So if you are trying to connect it from outside, you are not able to, but if you are connecting into the jump server, because it is already in the public subnet, you can SSH into it. And because private server and the jump server both are in the same VPC, internally the jump server can connect to the private server. So let's move to the console and let's see this in action. So these are the quick steps to create the NAT gateway, but having said that, let's move quickly onto the console and start then and there itself. So currently we are in the VPC section, and let's have a quick overview of the VPC. So I have one VPC which was created by default, and I have 4 subnets here. So as you can see here, I have 3 subnets, default subnet that was created along with the account. I have one custom subnet that I have created. Remember this image here where like we had 3 public and 1 private subnet, and as you can see here, for the private subnet I do not have any internet gateway associated, hence this is my private subnet. Now with the rest of the subnet, as you can see in the route table, this is the main route table and it has a internet gateway associated to it. So all these subnets are public and have public access. So in EC2 instance, I have a jump server as I had shown in the image, and using this utility I connect to the jump server from my public internet using SSH, and I'll be using this jump server to connect to the new instance that I am going to launch now. And this instance I will be launching in the private subnet that I showed you, which as of now doesn't have any back connectivity to internet, because it doesn't have any association to any internet gateway. So let's go back to the dashboard. So the instance is getting provisioned, and you can see now that we have the private server created. So we don't have any public IP associated. We'll take the private IP, and using the private IP, I will use the jump server to connect into my newly created private EC2 instance. So one thing that I'll have to do is that I'll have to copy the private key into the jump server, the private key for the new instance that I created. Let's verify if that's uploaded. Yes. So now I will use the SSH command to log into my private instance. And because the permissions are not changed, let me change it to 400 and now attempt. So here it is successfully connected to the private instance. Now let's check if this instance has any internet connectivity as of now. So I'm trying to ping Google, but as you can see here that it's not replying back with any data. Hence it is proved that this instance doesn't have any access to the internet or back connectivity to the internet yet. So let's go back and try to create the NAT gateway. So navigate to the NAT gateway from the left section, and please ignore this NAT gateway I created earlier. It's deleted now. I'll create a new NAT gateway called demo NAT. Select the public subnet. I'll create AP South 1A. Select the AP1 South A public subnet, and select an elastic IP address and click on create NAT gateway. With that, all these steps to create the NAT gateway is done. So now we will select the custom route table, and we will edit the routes to have the routing for the newly created NAT gateway. Just follow these steps and click on create. and with that the configuration part is done, and we can go back and check. So now we need to go back to our instance and check the connectivity to the internet is now working or not. So we again ping google.com and see. So this configuration takes some time to come into effect, so just wait for a few seconds. And as you can see here, now that the connectivity is there, we are getting the reply from Google server. So now our next step would be to update the OS and see, and as you can see, this is successful. So hence we have the connectivity from the instance to the internet, but not the other way around. So what it means is that while instance can connect to internet, if I take this private IP address, and even if I have a HTTP server running on my server, on my instance, if I use this IP, because it is a private IP, they will not be able to connect back into the instance. So that's all for this video. Keep watching this series, and I have many more topics to come up. Thank you.